Hi everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder how babies learn so much so fast? This is a fascinating question scientists are exploring. Think about it, babies and young children soak up language objects and the world around them at an incredible speed. Compared to the most advanced computer learning programs, they are like little learning superheroes. Scientists think a big part of this superpower comes from the regular everyday activities they participate in. Like how a child might learn the word pomegranate because they always see it during snack time. But studying this has been super tough because we haven't had great ways to look at what kids actually experience day to day. That is where this new research steps in. This research uses really clever new technology called video question answering models, or video QA for short, to peek into the everyday lives of young children through their own eyes. Imagine a tiny camera worn by a child, recording everything they see. The researchers collected a massive amount of this egocentric video data from 31 different children, totaling over 868 hours. They then used these video cam models to automatically figure out what activities were happening and where the child was for 1,500,312,485 short 10-second video clips. This allowed them to analyze the what and where of a child as daily experiences automatically, which is a huge step forward. So the big idea here is that children learn super efficiently because they leverage the patterns and regularities in their daily activities. Think about it, meals happen regularly and involve specific words and objects. Play happens a lot. These predictable routines help children make sense of the world and link words to things. While scientists have long theorized this is important, actually studying it in detail has been hard. You need to watch and meticulously label thousands of hours of video. That is where the video QA models come in. They are like super-powered automated annotators. The team used a special dataset called BabyView, which captures video from a GoPro camera mounted on a child. As helmet, this gives us a truly first-person view of what a child sees. They took all the hours of video and chopped it up into tiny 10-second segments. That is right. If you have 868 hours of video, that is a lot of 10-second clips. Now, for the magic part, they used a video cam model called Video Llama 3. They fed it those 10-second clips and asked it to tell them what activities were happening, where the child was, and even to provide a short description of the video. They didn't pre-program the model with a list of activities. Instead, they let the model answers help them build a list of common activities and places. Then, they refined the process, asking the model to choose from that list. This data-driven approach is key because it lets the data itself tell us what is important. The model was pretty good at this, but sometimes it struggled, especially in dark rooms or when the camera was just pointed at the wall. About 0.4% of the time, it just couldn't make sense of the clip. To make sure their automated annotations were decent, they had human coders look at 100 of the video clips. The human coders rated the quality of the text descriptions and tried to label the activities and locations themselves. They found that labeling activities can be tricky even for humans because sometimes multiple things are happening at once in a 10-second clip. For example, a child might be reading while also sitting. When they allowed coders to list all ongoing activities, the agreement between the model and humans improved. This is important because it tells us that everyday human experience is messy and not always one single neat activity. So what did they find? First, as you might expect, some activities and places were way more common than others. Playing was the dominant activity, which makes sense given how much kids play, and the living room was the most frequent location. This skewed distribution, where a few things happen a lot and many things happen rarely, is actually thought to be super helpful for learning. It means children see certain patterns repeatedly, which helps them learn more efficiently. They also saw that activities generally happened in expected places. Gardening was mostly in the garden, cooking was in the kitchen, but some activities like playing and exploring happened in lots of different places. Interestingly, they found that even though there were common patterns, there was also a lot of variation from child to child. Some kids spend much more time watching TV than others, while nearly all kids played a lot. This shows that while there are general trends, each child's daily experience is unique based on their family's routines and preferences. They also noted some early signs of developmental changes, like younger babies spending more time crawling and older babies watching more TV. They also looked at how long activities lasted. They found that reading tended to be the longest activity in contiguous blocks, followed by playing, eating, and watching TV. They think these durations might be underestimated because sometimes an activity like eating is made up of smaller moments, like drinking and conversing, that the model might see as separate events. This is a really cool part. Activities don't just happen randomly. They often follow patterns. For instance, cooking often leads to eating. The researchers mapped these transitions and found that certain activities are very likely to follow others. Walking, for example, often goes with exploring or playing, but not usually with eating or cleaning. These transition regularities are thought to help children predict what is coming next and understand cause and effect. Even within the same activity, there can be a lot of variety. The researchers looked at the descriptions the video Kia model generated for each clip and used the technique to see how similar these descriptions were. They found that activities like playing had a huge range of descriptions, showing how many different things count as play. But for an activity like reading, they saw clearer subtypes. Some reading clips involved the child being close to a book, while others had the caregiver holding the book further away and reading from it. This kind of detailed understanding of subclusters within activities can help us understand the nuances of what children are exposed to. They also looked at the motion data from the child's helmet. They found that certain activities were associated with more head movement, like crawling or walking, while others, like eating in the dining room, involved less movement. This adds another layer of understanding about how children's physical experiences differ across their day. So what does this all mean? This research shows us that we can use advanced AI tools like video Kia models to automatically study the rich and complex daily lives of children. This is a huge leap from needing humans to painstakingly label every moment. They found that children's experiences are characterized by skewed distributions of activities and locations, and importantly, by structured temporal transitions between activities. The fact that some activities and locations occur much more frequently than others, but there is still wide variation across children, is super important. It suggests that while there are common environmental supports for learning, each child's developmental journey is unique. The structured transition probabilities, like cooking leading to eating, provide predictability that likely aids learning. And the ability to decompose activities into subclusters, like different types of reading, reveals the fine-grained nature of a child's learning environment. The researchers also point out an important limitation. The video Kia model detects what the child is seeing, not necessarily what the child is doing. While often correlated, they are distinct. Also, the data collection depended on parents being able to record, so there might be an overrepresentation of certain activities. This work has significant implications for building better AI models that can learn more like children. Current AI models often train on very neat single-activity video clips, but real life, especially for a child, is messy. Activities overlap, they transition, and they occur within broader contexts. Understanding these regularities, both within activities and between them, is crucial for creating AI that can learn efficiently from complex real-world data. It is about moving beyond curated datasets to understanding the dynamic contextual nature of learning. This research paints a vivid picture of the incredible learning environment children are immersed in. It highlights how the predictable patterns in their daily routines, the rich sensory input, and the sequencing of events all contribute to their remarkable ability to learn. For AI development, it suggests we need models that can handle this messiness, learn from redundancy, and understand the temporal flow of information. It's a reminder that by studying how children learn, we can build smarter machines and gain deeper insights into human cognition itself. What do you think about these findings? Does it change how you see a child's day? Let me know in the comments below. And if you found this interesting, please hit that like button and subscribe to RUBIN'S Mind Lab for more breakdowns of fascinating psychology research.